The moment now we are going to important chapter. Now we are going to the important chapter, electromagnetic induction. The important chapter, electromagnetic induction. When I say moment electromagnetic induction, the moment it's electromagnetic, electromagnetic. That is, electricity is connected with the magnetic. You know very well, electricity and magnetism are perpendicular. This is the theory. Already they proved that this theory also. Electricity and magnetism are perpendicular. And induction. That means what? Induction. Induction means you are producing the electricity, or you need not worry about magnetic field. You are producing the electricity due to induction. Due to induction means what? Huh? Induction means what? Induction. Induction means external field or external source. You are producing the electricity due to external source. Some source you are making it. Some sources you are making it. Okay. Now let us assume this is the wire. This is a wire. There is no current. Nothing is there. Simply we are taking it as a wire. What I am doing, I am bringing some external object. Any object, any external field or object I am bringing. What it is doing, it inducing the current. So when the inducing current means, if this wire is connected to the bulb, means what it will happen? The bulb will glow. But I remove if I bring the external object outside means, or far means, what will happen now?
The bulb doesn't glow.
No, the current will not flow here. So this one is connected to the bulb. So bulb will not glow. So that means something generated. Some electricity is generated. You need not go for megawatt. You know, right? Megawatt, kilowatt, nothing you can go for. You need not worry for very big thing. You can go for simple bulb, a simple 0 watt bulb. 0 watt bulb you can means it consumes very less current. Very few volt it will few volt it will consume. Not even few volt, it will consume in the range of millivolt range. Simple bulb you take connected to it. So I am bringing some external source. So the current is induced in the wire. So it is, since the wire is connected to the bulb, so it will start glow. So that means due to some external field or object, I am inducing the current that helps to glow the current. That helps to glow the bulb. So that is the means for electromagnetic induction. Obviously the current is produced, magnetic will be produced perpendicular to the current. So the current is induced, magnetic field is perpendicular to the current, by which current is induced by induction. So that is electromagnetic induction. Something which helps to produce the current. So in this scenario, the Faraday performed the 3 experiment. So what is the Faraday performed 3 experiment? First he has taken coil connected to the galvanometer. Okay. Then he bought the magnetic field perpendicular to the coil. So what happened now for the first experiment? Current is induced. When the current is induced, when the magnetic field is perpendicular to the current, when the magnetic field is perpendicular to the current, what will happen? When any wire, you can take generally coil. Any coil is perpendicular to the magnetic field, what will happen? Current is induced in it. So the current is produced. The production of current is showed in the galvanometer. This is experiment number 1. Then in the same scenario, coil 1, he produced in the second experiment, he performed the coil which is smaller than the coil 1. So then he bought the near to the coil 1. Then he bought the coil near to the second small coil to the bigger coil. What will happen? Again the current is induced in the coil. Again the current is induced in the coil 1, which is bigger one. Because the second coil that he second coil is designed is very smaller than the first one. First coil has the bigger coil, second one has the smaller coil. Then in the similar trend, he has taken the 2 coils and inserted the rod to its in between. Inserted a rod in between. What happened is again he has observed that a current flows on the bigger coil, not the smaller coil. That is first coil. The current force. That means any magnetic field perpendicular to the, if the magnetic field is perpendicular to the current, due to presence of external object, immediately you can see the current will flow. Current will flow. So this now what is here the rod?
Third experiment.
That is the third experiment. What is the rod here? Iron rod. Okay. How he inserted? He inserted in the center of the
Coil.
first coil and second coil. So both are connected. So both first coil and second coil, how is connected now? First coil and second coil, how it is connected?
Center.
No, not center.
Inside, just inside that.
How first coil and second coil is now connected? Connected. First coil and second coil is connected by a rod. By a rod. Coil is nowhere
Connected by the rod.
rod with nowhere connected. First he performed the nearer place. Second, in the second thing is he bought very far. But what is experiment number 2? Experiment number 2, he bought the coil nearer. Second coil brought nearer to the first coil. But in the third experiment, the second coil is not brought near to the third coil. Second coil and third coil are very far, but it is connected via rod. You understand the concept now?
Yes, sir. Second one தள்ளி வச்சாதானே current flow.
No. It has to bring nearer. Second coil in this experiment 2. No, if it is very far, means how the current will flow? How current will flow if it is bought very far?
Okay, sir.
So
But you tell that shifting away from the first coil
no, shifting away towards the coil.
towards the coil.
Towards the coil. So towards the coil means that both should be nearer. Both the coils should be nearer or closest one. So now the two coil 1 and coil 2 are connected via both the coils are connected by the distance. It's a very short distance. If you bought two coils together, you will get the, if you bought two coils together, you will get a current. But in the same scenario, if you go for experiment 3, what will happen? If you bring the coil is very far. If you bring nearer the second coil to the first coil, you will get the current. That is experiment number 2. But in experiment number 3, if you bring, it's very far. Second coil and third coil, first coil and second coil is very far. But how the current flows? Due to presence of rod. That is inserted between the center of first coil and second coil. So now he observed that the current. Now he observed that current flows. So it is due to. This is the electromagnetic induction. If you, now we can go straightly. Now we can go straightly to the. Now we can go to the just out of 3 experiment, just third experiment you can take. So if you go for third experiment, what is specialty there? What is specialty there in third experiment?
The current will conduct through the iron rod.
No, current is obtained after insertion of iron rod into the center of the coil. Center of the coil. Okay. So this is the. No, I am asking about this experiment. What is specialty about it? Do you understand my question?
Yes, sir.
Specialty is different from experiment. Experiment is one I described to you. Okay. Experiment is one that I described to you.
Two coils kept away also current.
No, if two coil kept away, the current if the two coil is kept away, normally if two coil current away, the current will not flow. If the coil is brought nearer only, the current will flow. What is specialty about the experiment number 3 compared to experiment number 1 and 2?
Rod.
Huh?
Rod inserted in the.
If you inserted a rod, that is due to thing. So this is what you telling, that's a specialty due to presence of rod. Specialty, that's the experiment. You just repeating what I am telling, that's all. I explain the experiment, that's all. I didn't say anything, I just explained the experiment. I am asking what is specialty in that? Specialty. You didn't understand, no? Specialty in experiment number 3, okay? He taken rod, okay, and inserted to the coil 2 and coil 1, okay? Now we go to experiment number 1, okay? So forget about experiment number 2, okay? We don't want experiment number 2, okay? In experiment number what is doing? He is taking coil etc. And bringing the magnet towards the it, okay? Now current flows, okay? Current flows. But now he comes for experiment number 3. He is taking 2 coil and inserting the rod inside that things, okay? Now the current flows. Here the specialty. Why he is taking 2 coil? He might have taken 1 coil, no?
First experiment lo electrons pass agudhu.
Huh?
Electrons.
Huh?
Flow of current pass agudhu coil 2 la irundhu 1.
Coil 2, what? You understand first my question. Experiment number 1, he is taken coil and 1 magnet. He got the flow of electron, which he got a current. That's all over. Experiment 1 is over. Now in experiment number 3, he has taken 2 coil is taken and insert a rod inside between them. Okay? Now let us assume why he has performed 2 coil. Instead of that, he has taken 1 coil. No, 1 bigger coil he can take and insert a rod inside between, so he can observe whether a current is flowing or not. Why is that's the specialty of the experiment number 3. Bigger, no, you can take any one coil you take. In experiment number 3, you go to experiment number 3 now. You forget about experiment number 2. Perform the similar way to experiment number 1. Take 1 coil out. If you take there are 1 bigger coil, 1 smaller coil. If you just take smaller coil out. Okay. Now what you will get? What now? Which coil will remain? Which coil will remain? If you take out a smaller coil, only big one will remain. Okay. Now insert the rod to it. The current will flow or not? The current will not flow. Current will not flow. That's why he performed 2 coil. It's not a simple experiment. Your current will not flow. There it's there he performed means he has taken coil and magnet. Magnet have a magnetic power. But iron will have iron as general will have a magnetic power. It will attract towards the magnet. It attracts to the magnet, that is different. But it will not show a magnetic power. If you see anything is there means anything, if you bring the iron rod towards the magnet, it will attract it. Okay, that is different. But will it show something like that, North Pole and South Pole? No, it will not show. So that's why he has taken 2 rods, then he inserted towards iron rod towards it. That's the specialty of this experiment number 3. You understood now?
Yes, sir.
You understood now? That's the specialty of this experiment number 3. So you need 2 coil, then only the current flow, otherwise the current will not flow.
Okay, sir.
So you did understand or should I repeat once again?
Yes, sir. We will
Okay? Okay?
Yes, sir.
So you can take any coil, whether it's smaller coil or bigger coil, that doesn't matter. Number of coil present should be 2, then you have to insert the iron rod, then only the current will flow. Okay? So all of them having notes, no?
Yes, sir.
You have taken photocopy from her?
Yes, sir.
All the chapters, plus 1, plus 2.
Plus 1 இருக்கு, sir.
Yeah, you have to take, no, everything you have to take.
இல்ல, plus 1 note வந்து அவங்க வச்சிருக்காங்க.
Oh, they are having the thing. At least, okay, you have taken plus 2, right? Okay.
Then magnetic flux.
Magnetic flux. Okay, I will ask one more experiment. Now we go for experiment number 4. Okay?
Okay, sir.
Okay? So in the 2 coil, where if you keep No, why are you laughing? Huh? No, why are you laughing? Huh?
சொல்லுங்க சார் சொல்லுங்க.
Experiment number 1, 2, 3. All three got it. Okay, now experiment number 4 I will go. In the experiment number 4, I am taking magnet. I am taking one magnet. So where you will keep the magnet so that current will flow. In experiment number 3, in experiment number 2 or 3, where the current flows?
Between the
Big
big coil.
big coil. Small coil is a one. A small coil we are having the key only. Smaller coil. Okay, smaller coil having the key. Only in the bigger coil the current will flow. Okay.
In experiment number 4.
In experiment number 4, let us assume you need where the current will flow. Where current has to flow.
Big one.
Huh?
You here also you taken 2 coil sir.
Here also I am having to experiment number 3. In experiment number 3 I am taking out rod. I am experiment number 3 I am taking out rod. I am rod. So what remains here? Coil 1 and
Coil
2. Okay, 2 coils is there. Now where the current will flow generally? In coil 1, not coil 2. Coil 2 is connected to the key. Okay, coil 2 is connected with the key. Okay, so if I bring the magnet, where I am bringing the one magnet. Okay, so where I have to place the magnet so that current will flow?
near to the coil 1.
Near to the
Coil 1.
near to the.
Coil 1. Center.
So all the option you are telling. You are telling near to the
Coil 1.
coil 1. Coil 1 is bigger or smaller?
Bigger.
So coil 1 is bigger, coil 2 is smaller. So you are telling that coil. So your current has to flow means that you have to bring the
Nearer to the
nearer to the one. Okay, next you.
Center.
Center.
We remove the rod.
Okay.
So அதுக்கு பதிலா நம்ம magnet கொண்டு வரோம்.
Okay.
So center and coil 1 को coil
Coil 1 between coil 1 and 2. So yours? Huh?
magnet வைக்கும்போது இந்த iron rod வந்து அதுல attract ஆயிடும்.
No, iron rod we are removing it. We are removing. No, experiment number 3 we are removing the iron rod. That's all. In experiment that's all. We are going for experiment number 4. What we are doing is experiment number 4. In experiment number 4, experiment number 3 we are taking it. We are removing the iron rod. That's all. Everything. Huh?
Both coils.
We are removing the rod and throwing away. That's all. Rod is not connected. Now what is there? Coil 1 and coil 2. Coil 1 is bigger. Coil 2 is smaller. Current will flow in the coil 1 and in coil 2 it is a key. Only key is there. Just you have to press the key. That's okay, fine. Okay. Now where you will place the magnet? Where you will place the magnet?
The coil 1.
Near to coil 1.
Then only current is induced.
Current is induced. Okay. Now she is telling that. So you are telling that. So both of them telling C1, which is bigger coil. Then bigger coil. Then you are telling us a center, right? Yeah, no, I am asking the question. First, did you understand my question?
Yes.
First, you tell me the answer. Then I will tell the answer.
That's the answer. C1. Coil 1 bigger coil கிட்ட வெச்சாதான் induction ஆகும்.
Yeah.
ஆனா
No, it should be in the center. Why it's in the center? Center. Rod, but we are removing the rod. Rod is connecting both the coil. Now instead of that, magnet is connecting both the coil. So the magnetic field is perpendicular to the coil 1 and 2. So coil 1 and 2. You understood or not?
Yes sir, understand.
No, I'm suspecting this. You understood or?
Rod எடுத்ததுக்கு பதிலா
Ah.
rod வந்து ரெண்டத்தையும்
Correct பண்ணுங்க. So you have to keep the no. What I'm asking is that did you understand or not? I will repeat once again. Otherwise,
இல்ல சார்
you have understood no? If I not understood, just tell me. I'll repeat once again. Okay?
புரிஞ்சது.
So you have to keep rod in the
Between
center between the two coil. Then only the current will flow. See, this is the experiment number 4. That's all. Like that, they might have performed 10 experiment. In that, the best 3 experiments they might have published it. That's all.
Okay sir.
This is not published. When it published? These and all published almost 2 century back. 2 century back.
2 century back.
1830, 1820, something like 1820, 1920, 2020, almost 2 century back. Now you go for magnetic flux. So magnetic flux is same as, magnetic flux is defined as, magnetic flux is defined as rate of change of magnetic. No, rate of change is defined as rate of change is defined as the amount that magnetic field flows per unit area. Okay, which is defined as B into A, BA cos theta. Okay. Now what you written? Magnetic flux.
Magnetic flux is the rate of change of magnetic field B.
Rate of change of magnetic field.
Field B that flows of given area A.
That field, magnetic field that grows in the specific area A. So it is phi is given by BA cos theta. So if there is a n area means n area means how many flux will be there? Total flux is equal to phi B1 dA1 plus B2 dA2 up to BI dAI. So I tends to n because we don't know how many flux is there. It could be n, anything. Okay. Then we go for Faraday law of induction. So the Faraday law of induction tells that directly proportional to d phi by dt, that is rate of change of flux that proportional to current, that is E is nothing but current, that is rate of flow of flux E is equal to minus d phi by dt. Okay. So what is here? What is E here? E is E is electric field. What it is? Induced EMF. E is induced EMF. Induced EMF. Okay. Induced EMF is directly proportional to minus d phi by dt. Now induced EMF is equal to minus n d phi by dt. N is number of turns in the coil. Then Lenz's law. What is Lenz's law? The polarity of induced EMF is such that it tends to produce the current which opposes the change in the magnetic field that produced it. Okay. Okay. Next is, what is next? EMF. Electromotive force. So the electromotive force is flux is given by B into BLX, where flux is given by BLX. Okay. So B is the magnetic field, L is the length, X is the breadth. So that means B into A. What is A here? B flux is equal to B into A. Now what is A here? Area. What is area? L. What is area here? Length into breadth, Lx. That's all. So flux is equal to now B into L into X. So now rate of change of flux is given by rate of change of E is equal to minus d phi by dt. What is E here? Induced EMF. E is equal to minus d phi by dt. So E phi is equal to d by dt into BLX. So you have to substitute that flux value here. So BLX. So if you take this BLX, you will get E is equal to minus BL dx by dt. Dx by dt. So dx, what is dx here? Dx by dt nothing but velocity, because rate of change of displacement is equal to velocity. So work done is equal to Q. First work done is equal to force into distance. Okay, force into distance. No, first you have to write in the momentum formula, linear formula. Work done is equal to force into distance. Okay, so here force into distance. Okay, see here that electric charge is that is traveled is Q, electric charge that is traveled is BLV. Then what is the force here? Q. Q is the charge that is flowing here. So the charge that is flowing here is Q. BLV is the force into distance. The W is equal to force into distance. So F is equal to F is equal to Q here. Yes, distance is equal to BLV. Okay.
Yes, sir.
E is equal to W by Q. E is equal to W by Q. W is equal to QVBL. So QVBL divided by Q is equal to E is equal to BLV.
Sir,
W is equal to Q.
Q.
W is equal to QVBI.
BI. Okay, sir.
So this what is so E is equal to BL. E is equal to BL. No, E is equal to BLV. Okay. What is E? What is here? What is here? E. Induced EMF. B is magnetic field. So magnetic field, electric field and magnetic field are both related via LV. So LV. So electric field is directly proportional to the magnetic field. So electric field is directly proportional to the magnetic field. So you understood?
Yes, sir.
Do you have any doubts, clarification, anything?
No, sir.
So now based on the Lenz's law, we are going to see how the charge and magnetic field are related. Charge and magnetic field are related. Did I give this equation? I is equal to E by R. I is equal to E by R. No? Okay.
I equal to del by Q by del by U.
No.
Del by 5.
Del by Q is equal to del by phi by R. Okay. So del by Q is what is del by Q here?
Rate of change of flux.
No, not flux. Delta Q. Delta phi is different from delta Q. Delta Q is equal to rate of change of charge. That is charge moving from one distance to the another distance. So what is so delta Q? How can you can write Q2 minus Q1. Q2 minus Q1 is equal to delta phi. Delta phi is the rate of change of the flux. Rate of change of the flux. So divided by R. R is the distance of the radius of that area. Radius of that area. So that means if the charge flows means the rate of change of flux divided by R is directly proportional to. So delta flux is delta Q is directly proportional to delta phi. Phi by R. So now What is eddy current? Now we go for eddy current. So we covered everything? Yes, sir. Eddy current. Now before that what it is? No. Before eddy current. Eddy current, no? Before that what it is? Lenz law we covered, no? Yeah. So after that eddy current. What is eddy current? The eddy current is one electricity induced in well-defined paths in the conductor like circular loops. Okay, yeah, when a piece of conductor subject to change in the magnetic flux, induced current are produced in them. Their flow resembles the swirling eddies in water. So this is called eddy current. Do you have this definition?
Yes, sir.
Do you have this definition? That is the electric current. When the electric current induced in a well-defined electric current is induced in a well-defined path like a circular loop, when a small piece of conductor subjected to the change in the magnetic field, magnetic flux, induced current are produced in them. So induced current are produced in them. The flow pattern resembles the swirling eddies in the water. The effect is this is called eddy current. So in the similar trend, so what is the application of the eddy current? It is used in the magnetic brakes in the train. Magnetic brake in the train means when the train movings, when the train so in between when the train before the station comes, where they will put the brake? Before? Yeah, before the station arrives itself, they will put the brake, and they apply slowly. If they put sudden brake in the station, what will happen? Train will jump out from the track. So you have to apply slowly the brake. This is similar to what we apply for the accelerator in the car. Did you drive the car? Did you drive car?
No, sir.
You have to apply slowly before that comes. Suddenly, if somebody passed away, means what will happen to the car? What will happen to the car? The car will jump from the car will throw from the road. It will jump into the side of the things. So you have to apply slowly. So that same principle only applied here. So the eddy current. The how it is there means the strong magnets are situated above the rails in some electrical power train. When the electromagnets are activated, that is when the magnets are activated. That is the electromagnets are situated above the rail, above the wheel. I think above the wheel. Above the wheel, the electric magnet will be there. When the electromagnets are activated, eddy current induced in the rail opposes the motion of the train. That is the current. If I oppose, that will be the opposite of it. That means opposite of it means what? You understand my question first? You didn't understand. The current, the magnet is the train. What is it? Wheel of the train is there. Just take one compartment. It has one wheel. One compartment. All the wheel. Just one wheel you take. You need not go for all the wheel. One wheel is there. Above it, what it is? Above it, it is the magnet is there. Okay. Now I have to stop the train. So what technology I will use means first I have to activate the magnet. So how will you activate the magnet? By passing the electricity. It's not a simple brake. They are passing the electricity. This between what is then different? This car brake and car brake. Car brake.
Brake and train brake.
Yeah, train brake. In the train brake, you take one compartment, and you take one compartment, just one wheel you take. Okay. Now you go for car. Car you take same principle, brake. You have to apply for a brake. What will happen? That one is different from this, because there just physically you have to press it. Okay, physically you have to press the press the key. Physically you have to press the wheel. Not the wheel will not stop. Just adjacent to it, the rotating small wheel will be there in car. Big wheel is there. No, just adjacent to small wheel there. If you stop that small wheel, automatically the big wheel will stop. Okay, this is the principle of car. Okay, here we comes for train. Train comes means what will happen? We are applying the brake. When you apply the brake, you are not applying suddenly the wheel. What are we doing? We are supplying electricity to the. It's a type of that's a brake. We are supplying the electricity to the to the brake, which is above the wheel of train. What it does now? Now it become the magnet. So when its magnet is going, when its magnet when the two magnets will attract opposite. When when let us assume that has a north pole, means wheel should have a
South pole.
wheel should have a south pole. So then both of them will try to attract it. So that's a eddy current. So that current that we passed is eddy current. The second is electromagnetic damping. This is something. A galvanometer have a fixed core of non-magnetic metallic surface, and the coil oscillate. Eddy current generates in the core opposite to the motion, bringing the coil quickly to rest. This is simple thing. And induction furnace. Induction furnace also you know. Then electric power meters. Electric power meter is that what you see in the downstairs staircase you are entering. No, there some meters is there. No, that is electric power inductance. Then now inductance. What is inductance now? Inductance is the rate of change of flux linkage to the current. Rate of change of flux linkage to the current. Inductance is rate of change of flux related to the current, related to the current. So which is equal to n phi by I. N phi by rate of change of flux related to the current, and it is equal to n phi by I. What is n here? Number of turns in the coil. Flux is the magnetic flux. I is the current. So now we are going to see how the electric current is induced by the rate of change of produced by the another coil. So now the inductance is divided into two parts: mutual inductance and self inductance. So for mutual inductance, what is mutual?